Let us read this question. A uniform half meter rule can be balanced at 29 centimeter mark when a mass 20 gram is hung from its one end. A. Draw the diagram for the arrangement. B. Find the mass of the half meter rule. C. In which direction would the balancing point shift if 20-gram mass is shifted inside from its one end? So let's do part wise. First thing is important here is that it is a half meter rule. So remember that it is not 100 centimeter now, it is 50 centimeter. Half a meter is 50 centimeter. So now let's first draw the diagram. So here is a complete ruler, let's say of 50 centimeter. So at 29 centimeter mark, it is balanced. So our fulcrum where it is getting balanced it will be placed at 29 centimeter. So I've taken this end and drawn 29 centimeter from here. So the remaining length will be 50 minus 29, that is 21 centimeter. So at the other end, what is happening? A mass of 20 gram is hung. So it will have a vertical downward force due to gravity, which will be 20 gram force. The one force is acting here. Now, uh, draw the diagram of the arrangement. So we have done the diagram of the arrangement, but one thing is missing. What about the mass of this ruler? Okay, so mass of the ruler, we can imagine that it is acting at the midpoint of the ruler. So if it is 50 centimeter at 25 centimeter, the weight, entire weight of the rule will be considered as acting. So this is W I have mentioned with weight of the rule. So that is why it is getting balanced here at 29 centimeter. Otherwise, it should have balanced at 25 centimeters. But because we have shifted it little bit this side, that is why this mass is necessary to balance that moment. Now if you want to know the mass of this ruler, we just want to know the weight of the ruler and then we can infer from there that what is the mass. So how far this 25 centimeter will be from this fulcrum? It will be 5 centimeter. Oh, sorry, it will be 4 centimeter because 29 is total, 25 is still here. So the distance between this point and this point will be 4 centimeter. So we can calculate the moment due to mass of the ruler, and then we can calculate the moment due to this 20 gram, and then we can apply principle of moments to get this W. So here it is, we are applying principle of moments F into 4. F is W I have taken into 4, it will be equal to 20 into 21, and if we solve it we'll get 105 gram force, or we can say the mass of the ruler is 105 gram. So that's why it is downward force is 105 gram force. So mass of the half motor ruler is 105 gram. Now the next part, if we move the 20 gram mass to the left inside, then the torque will be reduced. Clockwise torque will be reduced. The balancing will also need to be shift left side to reduce the anti-clockwise torque or towards 25 centimeter mark. Let's understand this. So what it is saying at the C option, in which direction would the balancing point shift? Balancing point is this, where this balancing point will shift if 20 gram mass will be shifted this side. See, as of now, it is balanced. So this we have calculated 105 and this is getting balanced here. So this moment is equal to this moment. But what if we shift this inside? Okay, so they're not told like how much we have to shift inside. It's just told that we have to make it shift inside. So what will happen? The movement due to this clockwise movement, which it was happening from here due to this 21 centimeter, that will be reduced. So its moment of force, clockwise movement will reduce. So this will win and it will create an anti-clockwise movement. So the balance will be imbalanced. So what we need to do to compensate that, we will reduce this forces distance also. So we have to shift this also inside to balance it. If you see intuitively, you will get it. If this mass is coming this way, we need to, in the same direction, we need to move the fulcrum. So this is what the answer is. Now let's go to the next question. A, a uniform meter rule of mass 100 gram is based on balanced on a fulcrum at 40 centimeter mark by suspending an unknown mass m at a mark 20 centimeter. Find the value of m. We need to find the value of m. Let's we will read as we go along. Let's find the mass m first. For this numerical, what we can do is, because there are many lengths, so what we have done, we have drawn one ruler here and have made some markings like this is 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100, so that we know where we are putting what. So now if you'll see with these markings, it will be very easy to put and determine how much length is there. So see, 100 gram is balanced. This ruler has 100 gram force, so that will be acting at the midpoint, so its cog will be here. So 1 2 3 4 5, so its cog is here, so entire ruler mass can be acted, mass seem to be acted from here, or the weight will be downwards from here. So this is what I have denoted: 100 gram force, weight of the rule, downwards at 50 centimeter mark. What next? It is balanced on a fulcrum at 40 centimeter. So the fulcrum will be at 40 centimeter. See, 1, 2, 3, 4, 40 centimeter. The fulcrum is placed. And we now want to know unknown mass at the mark 20 centimeters. So see, 10, 20. So the m mass will be here. So let's say its force will be m gram force. So now we need to find this one. To in the balancing act, this moment will be equal to this moment. So we can see it like this. So see the different the while putting the formulas of moment of torque, moment of force, we need to apply the distance from the pivot. So here the distance will be 20 centimeter. For this weight, that distance will be of 10 centimeter. So we'll equate it: m into 20, it will be equal to 100 gram force into 10 centimeter. So if you see centimeter, centimeter will get cancelled out, and mass will get a 50-gram force. So the mass m is of 50-gram force. So this now we know, right? Now let's say what is next? Uh, to which side the rule will tilt if the mass m is moved to the mark 10 centimeter. Let's see. So it was here, see, it was at this 20 mark. Now we have moved and put it here inside. Instead of here, we have shifted this side. So what will happen to its movement? Its movement will increase because you are increasing the distance from the pivot. So its movement will increase. So that is what they were asking, and they are asking us to calculate this. Let's see, tilt. Yeah, to which side the ruler will tilt, and what is the resultant moment now? So let's see. So we have kept it like this. We can calculate this moment will be 50 into 1, 2, 3, 30 centimeter. Remember, see, from pivot we have to take the distance of 10, 20, and 30. 30 centimeter. So 1500 gram 4 centimeter. For this, it will be 10 100 into 10, so it will be 1000. So the resultant is anti-clockwise 500. So that is the resultant. Let's do the next part. So the movement will be of 500 gram per centimeter in the anti-clockwise direction. It will be moving like this. We can balance this. What is the next option? Yeah. How can it be balanced by another mass of 50 gram? So if you see the diagram, so if it is gone here, we are seeing that there is a now net anti-clockwise moment of which will rotate it like this by 500 gram per centimeter. So we need to put a mass of 50 gram. So where we should put, because it is now net moment is this side anti-clockwise, we'll put it here on the right side of the pivot, so that we get a clockwise moment. So 50 will be put at some distance. Let's say that distance is d, and solve for it. So 500 gram force centimeter, which is the resultant one, will be equal to 50 gram force. 50 gram mass we will put at a distance d. We will calculate for d, it will be 10 centimeter. So from the this pivot, it should be 10 centimeter from, or where the exactly the midpoint of the ruler is. And if you see from the start somebody asked, then it is 50 centimeters. So that is the answer here. Okay, let's go for the next question. So this is a uniform bar of length L meter is supported at its end like this. okay, like this. Weight W at its middle, so it is balanced like this, and there is a weight at the midpoint of this uniform bar. Find the reaction R1, R2 at the ends. So we have to find the expression for these in terms of this and length. Let's see how we can do. They have given a hint. In equilibrium, R1 plus R2 is equal to W, and R1 and L2 is equal to R2 L2. So this is actually hint clearly tells us, how what will be the answer. But let's proceed how we can do. So first thing is about R1 and R2. You can see the word for vertical equilibrium, the upward forces and downward forces should match. So R1 plus R2 will be equal to W. So that we can clearly say that's why the hint they have given. And second thing about at this point, these movements should be equal. So R1 into L by 2, because see L is the total length. Till here length will be L by 2, half of L. So this moment will be equal to this moment. That's why we are counting at this point, because this is in equilibrium. So the movement should be equal. So their movements will be equal. R1 into L2 by L by 2 will be equal to R2 into L by 2. L by 2 will get cancelled, and R1 will equal to R2. So both reactions will be of equal magnitude, that we can say. And also the vertical, if we say the vertical imbalance, we say R1 plus R2 will be equal to W, or R1 plus R1, because they are same. Let's say R, so 2R is equal to W, or R will be equal to W by 2. So both the reactions will be half of the weight. So if you see from the common sense, we can solve this question like this, because it is supported from midpoint. So half of the reaction is coming from here and half of the reaction is coming from here.